Now we're going to be deriving using what's called a chain rule. We're going to be deriving using chain rule. So what is the properties of chain rule saying? Suppose you have a function and that function is raised to any what? To any number, any exponent, ne? And let me say n is an element of what? Of I can say integers, any number, integers, ne? So if they ask you to derive this thing, find d over dx, what is the derivative of that thing? A derivative of that thing, you are going to take that exponent n here, you drop it, you keep the inner function, then you subtract 1 from the exponent, then you multiply by the derivative of whatever is inside the whole function, yeah? Or you multiply by the derivative of the inner function. Understand? And another way can be like this. You're going to have a function inside a function, a function inside a function. Understand? Therefore, they ask you to derive that thing. You are deriving with respect to what? To you. You are going to do what? First thing first, you derive the outermost function. Therefore, you are going to have f prime of g of u multiplied by what? The inner function, g prime of u multiplied by the innermost function, u prime. Understand? That's how you are using what? That's how you are using a chain rule. Yeah? So let's do a quick example of using chain rule. Yeah? So suppose you have a function like this. We have a function called a number 1. Let's say number 1. The function is 2x plus x squared to the power 7. If you expand that thing, if you expand this thing 7 times, you expand it 7 times to the point whereby you do what? You are gonna waste time. You'll waste so much time because expanding that thing will take you so long. Ne? So there is a way using what called a chain rule. You are going to say d over dx. You are deriving with respect to x. Then you say equal sign. First thing first, you do what? You take the 7. You do what? You drop it. Ne? You keep what? You keep the inner function. Ne? You say 2x plus x squared. Therefore, you subtract 1 from that 7. You say 7 minus 1. Therefore, you do what? You derive with, you multiply by the derivative of what? Of whatever is inside that function, which is going to be 2 plus what? 2x. Ne? So that is how you are deriving that thing. Then for your final answer is going to be 7, 2x plus x squared. Therefore, you have what? 6. You have 2 plus 2x. Ne? That's how you can find the derivative of that thing. Ne? So let's check another question. Another question can be rewritten like this. You have 2. Question number 2, they're asking you to find the derivative of this function, negative 2. First thing first, you are going to do what? You are going to take this exponent here. This exponent, you do what? You drop it. But first thing first, before you drop it, you don't have just to drop it without not telling them what you are doing. Ne? You must tell them you are deriving. You say d over dx. If you don't tell them, you will get a 0 because it's like you are doing something that they don't know what's happening. Ne? Tell them you are deriving. Ne? D over dx. You tell them you are deriving. Ne? So I'm dropping the 2. I'm dropping the negative 2 actually. I keep the inner function. I subtract a negative 1 from that negative 2. I multiply by the derivative or the derivative of what's of the inner function, which is x squared plus 1. The derivative of x squared plus 1 is 2x. Ne? Therefore, my answer is going to be what? Remember, this thing are what? Is the multiplication. Ne? Don't forget, don't leave it like that. We are going to have what? Negative 4x. Therefore, we have what? X squared plus 1. You have negative 3. You can put this thing back in the denominator, since well is a negative, ne? Meaning you are going to have negative 4x all divided by what? All divided by x squared plus 1 raised to the 3. Ne? That's how simple is that thing. So let's try and check number 3. Number 3, they saying they have f of x equals to what? X plus 30 x squared raised to 1. They are saying differentiate using chain rule. You are going to say f prime of x. Ne? Therefore, you do what? You drop the 1. You drop the 1. You have x plus 30 x squared. You subtract 1 from that thing. Ne? You subtract 1. Therefore, you multiply by the derivative of whatever is inside, which is going to be 1 plus 60x. Ne? Therefore, you are going to remain with what? Sorry for that. You are going to remain with x plus 30 x squared raised to 0. 1 minus 1 is 0. Therefore, you have 1 plus 60x. Any number raised to 0 is what? Is 1. Therefore, I'm going to remain with 1. 1 plus what? 60x. My final answer is 1 plus 60x. That's how you can derive that thing using what? Chain rule. Ne? So let's go to question number 4. Question number 4, they have what? They have y equals to what? 1 minus 7t. They say 1 over 2. Ne? So you are going to say what? You are deriving y with respect to what? With respect to, check the variable is what? Is t. It can be x, it can be m. Check the variable. You are deriving with respect to what? To t. Ne? Therefore, you do what? You drop this thing first. You drop 1 over 2. Then you keep the inner function. You subtract 1 from half, which will get negative 1 over 2. Therefore, you multiply by the derivative of whatever is inside, which is going to be negative 7. Ne? So my answer is going to be what? I take that negative 7 here. I multiply it by half. I'm going to have negative 7 over 2. Therefore, I have what? 1 minus 7t minus half. I take that negative in the what? In the denominator, since well is negative. Ne? Negative. I reverse the what? The what's this thing? I reverse the reciprocal. I have 1 over 2. 1 over 2 is the same as square root of 2. Ne? I mean square root. I'm going to do what? I take the 2, put it outside the square root, then I keep the function. I take this 1, put it here. Ne? Therefore, my answer is going to be negative 7 over square root of 1 minus 7t. Square root of 2, like this, is the same as root 2. This 2 is always invisible here. Ne? Keep that in mind. Don't be surprised. It's the same thing. Even if you press a calculator, you will get the very same answer. So let's try number 5. It's beneficial for you to pause the video and try these things by yourself. You have y plus 3y squared. So you are deriving what? You are deriving k. You say dk with respect to what? With respect to y. dy. Ne? So before you do that thing, start by simplifying that thing. Ne? You're going to have y plus 3y squared and what? 1 over 2. You're going to drop that 1 over 2. Then what? Keep that inner function. Subtract 1 from that what? That half. You're going to remain with negative half. Then multiply by the derivative of whatever is inside, which is y plus y 3y squared. The derivative of that is going to be 1 plus 6y. So my answer is going to be what? It's going to be I'm taking this thing back in that one, then I'm taking this one in the denominator. I'm going to have what? 1 plus 6y all divided by what? All divided by 2. Therefore I have what? I have y plus 3y squared 1 over 2. That thing is the same as what? 1 plus 6y divided by 2 square root of what? Y plus 3y squared. Ne? So let's try and check another question. Another question is question number 6. Number 6, it says let me see, I think I made a mistake here. Number 6 says says 4x plus 3 all divided by what? By 5x minus 2 all cubed. Ne? So you are going to do what? You're going to say what? D over dx. Ne? You say equal to, you drop the 3. After dropping the 3, you do what? You leave the inner function. You subtract 1 from the 3, you're left with 2. You multiply by the derivative of whatever is inside. So how can you derive this thing? For you to derive this thing, you have to do what? You have to use quotient rule. Ne? So the derivative of that thing, I'm using quotient rule. I keep the first function. I derive the first function. The derivative of this function is going to be what? Is going to be 4. Therefore, I keep the what? The one in the denominator. I say minus. I keep the first one, which is 4x plus 3. Then I do what? I derive the one in the what? In the numerator. I'm going to have what? I'm going to have 5. So I'm going to square that one in the denominator. 5x minus 2 all squared. Ne? So my answer is going to be what? Is going to be I can take this 3 and multiply it both that side and multiply it. It means I'm going to have what? 4x plus 3 all divided by 5x minus 2 raised to 2. Then 3, I'm going to have what? I can multiply that thing. I'm going to have 3. I have what? 4 times 4 is what? Is 5, 10, 15, 20 is 20. Is 20x minus 8. Therefore, I have what? 5 times 4 is 20, which is minus 20x. 5 times 3 is 15. Then if I have what? Minus 15 all divided by what? All divided by 5x minus 2 all squared. Ne? So if I check carefully here, these two things cancel each other. Therefore, negative 8 and negative 15 is the same as what? 2 plus 15, which is going to be negative 17. So negative 17 multiplied by 3 is going to be 51. So my answer is going to be what? Sorry for that, Carl. Is going to be 4x plus 3, 5x minus 2 all squared. Therefore, I have negative what? Negative 51. Negative 51 divided by what? Divided by 5x minus 2 all squared. Ne? That's my final answer. Let me try and check another question. Another question, it says what is number 8? It's number 8. And number 8, it says y equals to square root of x plus square root of 1 plus square root of x. How can you derive that? For you to derive that thing, start by simplifying it. Ne? You say y equals to, remain with x plus, you remain with 1 plus, you remain with what? With x 1 over 2 is for this square root. This 1 over 2 is for this square root. Ne? Therefore, this square root, it will have its 1 over 2, and that outermost square root is going to have its own what? 1 over 2. Ne? For now, you start deriving. You say dy over dx. Ne? So it's going to be equal to, I drop the 1 over 2, 1 over 2. I keep the inner function, x plus 1 plus, since what I'm keeping, let me just say that thing as square root, understand, and keep that one as a square root also. You see, therefore I do what? I subtract 1 from that negative. Ne? I'm going to be left with negative 1 over 2. Ne? So I derive with what? I derive with the inner function. The ratio of that inner function is going to be what? It's going to be 1 plus. Here, I'm going to use quotient rule, chain rule also. Understand? So I'm going to drop 1 over 2 there. 1 over 2. Therefore, I keep the inner function, which is this one. I keep this one. Now, after keeping that one, I can keep it like this. I subtract 1 there and remain with negative 1 over 2. Understand? Therefore, I do what? I multiply by the what? By the derivative of whatever is inside. Whatever is inside here. Ne? Which is going to be what? It's going to be 1 over 2. Therefore, I subtract 1 there. I remain with negative 1 over 2. That's how simple is that thing. So I start by simplifying. This one is going to the what? To the denominator, since what is negative. I'm going to have what? 1 over, don't forget this 2. 2 what? 2 square root of what? X plus square root of 1 plus root x. Ne? Multiply by what? Multiply by 1. This one is also going in a what? In the denominator. I'm going to have plus what? 1 over 2 square root of 1 plus root x. Ne? Therefore, multiply by what? Multiply by, this one is going to in the denominator also. This one. I'm going to have what? 1 over what? 1 over 2 root x. Understand? That's how you can solve that thing. That's how easy it is. Ne? I'm going to be left with 1, 2 square root of x plus square root of 1 plus root x. Multiply by what? I can treat those things as one thing, which is the same as what? 1 plus what? 1 over. I can multiply these things. I'm going to have 4 root x root what? 1 plus root x. If I want to simplify that thing completely, I can simplify this one. Ne? If you want this one, I can reverse this thing. Ne? Using the law of surds. A, B is the same as what? Square root of what? A multiplied by B. Meaning I can take this x, I multiply by this thing. I put them in the same square root. Ne? I'm going to have what? 1 over what? 2 square root of x plus 1 plus root x. Ne? Multiply by what? Multiply by 1 plus 1 over what? I have 4 square root of what? X multiplied by that. X multiplied by 1 plus root x. Therefore, you are done. Nothing more, nothing less. That's how we are going to use we're deriving using the so-called chain rule. Let me check another question. Another question, it says, it's number 9. It says what? Z equals to 3 square root of what? p plus 3p squared. Ne? They're asking me to derive that thing. I'm going to simplify it first before deriving. It's the same as p plus 3p squared 1 over what? 1 over 3. That one it comes from here. Ne? So I'm going to say I'm deriving z with respect to what? To p. So I drop the half, I keep the function, I subtract 1, I remain with negative 1 over 2. I multiply by the derivative of whatever is inside, which is what? 1 plus 6p. So my answer is going to be what? This one is going to in the denominator. 1 over what? 1 over 2 square root of p plus 3p squared. Multiply by what? This one can go back in the numerator. 1 plus 6p. Therefore, my final answer dz over dp equals to what? 1 plus 6p all divided by 2 square root of what? p plus what? 3p squared. Yeah. So let's check another question. It says what? Another question, it says we have a square root of 4 minus x squared. Ne? So you don't have a subject to the formula. It means I'm going to say what? D over dx. I say equal sign. I haven't yet started deriving. I'm simplifying. Ne? D over dx. You must not leave that thing before you start by what? By deriving. When I simplify that thing, I have 4 minus x squared 1 over 2. So now I'm starting to derive. I leave it alone. I drop the half. I keep the inner function. I subtract 1 from the half. I remain with negative 1 over 2. I multiply by the derivative of whatever is inside, which is this one. Is going to be negative 2x. Ne? So this negative 2's negative, and 2 and 2 will cancel, but then the negative won't cancel. It means the answer is going to be negative what? 4 minus x squared minus 1 over 2. This negative says I must put it in the denominator. I'm going to have negative 1 divided by what? Divided by 4 minus x squared 1 over 2 is the same as what? Negative 1 over 2 square root of 4 minus x squared. You see how simple is that thing? Very, very simple. Oh, I made a mistake here. I made a mistake. It was supposed to be 3 here. Let me fix that. I made a mistake. I made a huge mistake. Let me start that thing. But this one is correct. This one is correct. Let me fix that one of number 10. I made a mistake. So I'm going to have what? I'm going to have z equals to 3. Therefore, I have p plus 3p squared. So I'm going to simplify that thing before. It's the same as what? P plus 3p squared 1 over 3. Ne? So when I derive, I say dz over dp. I drop the 1 over 3. I have what? P plus 3p squared. I subtract 1 from 1 over 3. 1 over 3. When I subtract 1 is the same as when I subtract what? 3 over 3 is the same as what? 1 minus 3 over 3. 1 minus 3 is the same as what? Negative 3 plus 1, which is negative 2 over 3. Negative 2 over 3. I multiply by the derivative of the inner function, which is what? P plus 3p squared is going to be 1 plus what? Plus 6p. Ne? So when I simplify that thing, I'm going to be left with what? I'm putting this one in the numerator. 1 plus what? 6p. This one goes back in the what? In the denominator. I'm going to have what? 3. Then I have what? P plus 3p squared. Therefore I have 2 over 3. So remember, This 3 is going where? Is going here. Understand? This 2 is going here. Is the exponent of the function. Ne? I'm going to have 1 plus 6p. Then 3 square root of what? The 3 is going outside. Therefore I have p plus 3p squared. The 2 is going to be the exponent. Ne? Yeah. I rectified that mistake. This one is correct. This one is wrong. I made a mistake. It's wrong. So let's check another question. Another question says, we are having this question. We're having 10x minus 3, 1 plus x, all to the 4. So I'm going to say what? D over dx. I say equal sign. Equal sign. Before, now I'm still simplifying. I haven't yet started to derive. I don't remove that thing. Ne? So when I simplify, this thing is the same as what? 10x minus 3, 1 plus x. Ne? And then I have what? I have 1 over 2 all raised to the 1, all raised to 4. Ne? That 4 will multiply here, and it will leave us with what? When I multiply that 4 there, I'm going to have 4 over 2. 4 over 2 is the same as what? Is the same as 2. Ne? So I have what? D over dx is what? Is 10x minus 3, 1 plus x all squared. I can now use what? Chain rule. I drop the 2. I keep the inner function, minus 3, 1 plus x. I subtract 1 from the 2. I remain with what? With 1. Therefore I multiply by the derivative of whatever is inside. Multiplying those two functions, I'm going to use product rule. I derive the first one, which is this one. Yeah. I derive the first one. I'm going to have what? 10. I keep the second one, 1 plus x. Then I say plus. I do what? I keep the first one, 10x minus 3. I derive the second one, which is 1. Yeah. So my answer is going to be what? 2 into what? Into a 10x minus 3, 1 plus x. But then I don't see the need of, but then I don't see, there's a need. Then I have what? 10 times 1 is 10 plus 10x plus 10x minus 3. I'm going to have 2 into what? 10x minus 3, 1 plus x. Therefore I have 10 plus 10x, which is 20x. 20x. 10 minus 3 is what? Is plus 7. You see? That's how simple is that thing. Let me check another one. Another one, it says what? It says square root of what? Square root of x squared plus 1 divided by square root of x plus 1. I'm going to say d over dx. I say equal sign, equal sign. I start by simplifying. I haven't yet started deriving, hence I'm not removing that what? D over dx. This is the same as what? X squared plus 1 over 2 divided by what? Divided by x 1 over 2 plus 1. So there I'm going to use what's called quotient rule. This is f of x, this is g of x. So it means I know the quotient rule says what? The product of those two functions is going to be what? Equal to f prime of x multiplied by g of x plus f of x multiplied by g prime of x. So I'm going to be forced to find f prime of x. So f prime of x is going to be what? Is going to be the derivative of this function. So I'm going to use chain rule there, which is going to be 1 over 2 x squared plus 1. I subtract 1 from half. I'm going to have negative 1 over 2. I multiply by the derivative of the innermost function, which is what? X squared plus 1. Ne? So I'm going to have 2x. So these 2's cancel each other. I'm going to be left with what? With x over, I take this thing back in the denominator, over square root of what? Square root of x squared plus 1. Ne? Let me find g prime of x. G prime of x is going to be what? It's going to be 1 over 2 x minus 1 over 2. Yes. So I'm going to simplify that thing. It's going to be 1 over 2 root x. Now I'm putting those things back together. No, it's quotient rule, ne? So quotient rule is going to be a negative here. Why do I keep making mistakes? It's going to be negative, and it's going to be all divided by what? G of x squared. Ne? Don't forget. So our f prime of x is what? Is this? It's going to be x over square root of x squared plus 1. Then g of x is what? G of x is square root of x plus 1. Square root of x plus 1. Then I say subtract. Then f of x is what? Is square root of x squared plus 1. Square root of x squared plus 1. Then g prime of x is what? Is 1 over 2 root x. So g of x is what? G of x squared. I'm going to have what? Square root of x plus 1 all squared. That's the derivative of that function. Ne?